Hello students, let us start with fourth part of chapter 4. Lewis' concept is unable to explain the shape of molecules. The first simple theory that was put forward to explain the shape of molecules is known as valence shell electron pair repulsion theory. It is also called as Versaper theory, and today our topic is Versaper theory. This theory was given by Sidgwick and Paul, and the central atom is linked to the other atoms by covalent bonds which are formed by sharing of electrons. Thus, the central atom is surrounded by shared pairs of electrons, and there may be some lone pair of electrons also present. The stability of the molecule demands that it should have minimum energy. So, taking it into account, the main idea of Versaper theory is the electron pairs surrounding the central atom repel one another and move so far apart from one another that are no further repulsion between them. As a result, the molecule has minimum energy and maximum stability. Let us start with main postulates of Versaper theory. Number 1. The shape of a molecule containing only two atoms is always linear. Number 2. For molecules containing three or more atoms, one of the atoms is called the central atom, to which other atoms are linked. Third point. If the central atom is linked to similar atoms and is surrounded by bond pairs of electrons only, the repulsions between them are similar. As a result, the shape of the molecule is symmetrical and the molecule is said to have a regular geometry. Fourth point, if the central atom is linked to different atoms or is surrounded by bond pairs as well as lone pairs of electrons, the repulsion between them are different. So molecule will have irregular or distorted geometry, and we have to follow the order lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. And next point, the exact shape of the molecule depend upon the total number of electron pairs present around the central atom. Now, the method how to predict the shape of the molecule based on it. There are two cases of Versaper theory. In fact, it is divided into two parts. Case 1, when molecule in which the central atom has no lone pair. Case 2, when molecule in which the central atom has more than one or more than one lone pair. Let us start with the first case, when the molecule having only one lone pair. In these molecules, the central atom does not have any lone pair and it just have bonded pair. So starting the examples. First example is BeCl2. Then molecular geometry is linear. Shape is seen on the screen. See the linear shape with angle 180 degree and with only bond pairs and no lone pair. Next is when it has three bond pairs. For example, BF3, trigonal planar. It is clear on the screen. It is in form of a triangle with angle 120 degree. Next is molecule where central atom has four bonded pair. Here in this, central atom is located at the center with four substituents that are located at the corners of a tetrahedron. And tetrahedron, for example, CH4. 4. It is quite visible on the screen. So angle is 109.5 degree. Next is where central atom has 5 bonded pair. For example, PCl5, then the geometry is trigonal bipyramidal with angle 90 degree and 120 degree. Here is the most important reason which have been many times asked in question paper. 3 of the bonds are arranged along the central atom's equator with 120 degree angle between them. The other 2 are placed at the atom's axis. Axial bonds are at right angles to the equatorial bonds. Let us start with case 2. Molecules in which the central atom has one or more lone pair. Let us start with first type. Lone pair when it is 1 and bond pair is 2. This is case of SO2 and O3 and shape of the molecule is bent. It's clear on the screen there is presence of one lone pair. Now next case, when lone pair is 1 and bond pair is 3. It is shown shape will be trigonal pyramid and angle will be 109.5 degree, but it is reduced to 107 degree. Why it is reduced to 107 degree? Because lone pair bond pair repulsion is more than bond pair repulsion. This also happens in ammonia. It is one of the most important question. Next case, when lone pair is 2 and bond pair is also 2, then geometry will be tetrahedral and shape is bent. Angle between them should be 109.5 degree, but it is reduced to 104.5 degree. Why it is reduced? As lone pair repulsion is more than lone pair bond pair repulsion, which is more than bond pair repulsion, and example is H2O. When lone pair is 1 and bond pair is 4, in that case let us take example of SF4. It is trigonal bipyramidal. It is also called seesaw shape. So dear student, this topic is very important. Prepare your notebooks and draw all the shapes and write down all the geometries. Thank you.